I would like to recall first L'Hôpital's rule. Yes, we say L'Hôpital, not Le Hospital. Suppose that f and g are differentiable functions at x equals c, and that limit of f and g when x approaches c is 0, or the limit of f and g when x approaches c is any combination of plus minus infinity. Then limit of fx over gx when x approaches c equals to the limit of the derivative of x over the derivative of g when x approaches c. We also have written the shortcut of L'Hôpital rule. We now would like to see other indeterminate forms, and we will start with the indeterminate form of infinity minus infinity. This limit is of the form infinity minus infinity. There is a competition between the two infinities, because we have something huge minus another thing which is pretty huge. To eliminate the competition, we're just going to distribute x to the power of 2. And we get this limit. In this limit, not only that there is no competition, but a full support of one of each other, because we get here infinity times infinity, which equals infinity. Here's another example. This form is also infinity minus infinity. 1 over sine x when x approaches to 0 from the right is 1 over 0 plus, which is infinity. 1 over x when x is 0 plus is also infinity. We try first to simplify this expression by a common denominator. And we realize when we are doing this that this form is not anymore infinity minus infinity, but a much better one. This is now 0 over 0. It means that we can just go ahead and use L'Hôpital's as always. We get that. Don't forget to use the product rule for the derivative of x times sine of x. Now, we are going to substitute again 0 for the x to see what we get. A little surprise, we get 0 over 0 again. I would like to recall that cosine of 0 is 1 and sine of 0 is 0. So we will apply L'Hôpital again. It's really look not very nice, but it's going to give me the answer. I'm trying again to substitute 0. When I substitute 0 for the x, I get the following. I get 0 over 2 minus 0, which is 0. Obviously, I'm not going to use L'Hôpital's, but also it means that I'm done and I have the limit. The limit is 0. The indeterminate form 0 time plus or minus infinity. Example. Limit of x times ln of x when x approaches to 0 from the right. I would like to recall that this one is negative infinity when x approaches to 0 from the right. And this guy is 0 when x approaches to 0. Please memorize that the limit of ln when x approaches to 0 from the right equals negative infinity. I see a little problem here. I see a product. It is impossible to apply L'Hôpital's rule on a product. So what I'm going to do now, I'm going to try to make a quotient out of this product. And here's the trick. I'm going to divide by 1 over x instead of multiplying by x. We usually do the opposite. If I will ask somebody, what is 2 over 1 over 3? Then it is 2 times the reciprocal of 1 over 3, 3 over 1, which is 3, and we get 2 times 3. Here we really do the opposite. We have 2 times 3, and we like to write it as 2 over 1 over 3. Taking the reciprocal of 1 over ln of x is not going to work because it's going to be forever applying L'Hopital with no result. So I will take the reciprocal of x. You really have to think about it. If somebody will ask you what is ln of x over 1 over x, you know immediately that this is x times ln of x. This is a little difficult and confusing because we usually say that ln of x over 1 over x is x times ln of x, and we rarely say that x times ln of x is ln of x over 1 over x. When you see the indeterminate form 0 times plus minus infinity, you have to use this technique. Because now, see what I have now. This is negative infinity over infinity, and I can use L'Hopital. When you take the reciprocal of x, which was before approaching 0, you get 1 over 0, which is infinity. So it's not only that by doing this we get a ratio. We get such ratio that is going to be such that we can actually apply L'Hopitals. The derivative of ln of x is 1 over x, and the derivative of 1 over x is negative 1 over x to the power of 2. I hope you recall this one. You're allowed to use L'Hopital here, but you really don't want to, because first you want to simplify. If you still want to use L'Hopital, this is going to be like the example that I showed you before. It's going to be forever L'Hopital. After simplifying, we get the limit of x to the power of 2 over negative x when x approaches 0 plus, which can be simplified even more if you want, or you can use L'Hopital here if you want, because this is an easy L'Hopital. But why not simplifying and get the limit of x over negative 1 when x approaches to 0 plus? And we get 0 over negative 1, which is 0. And here is another example of the same indeterminate form. Limit of x times sine of 1 over x when x approaches infinity. You can see that the x approaches infinity when x approaches infinity, and sine of 1 over x when x approaches infinity is sine of 0, which is 0. So here again I'm going to do exactly as before. I'm going to divide by 1 over x instead of multiplying by x as I have right now. And I get that. Now the form here is 0 over 0, so I can go ahead and use L'Hopital's rule. Don't forget the chain rule. The derivative of sine of 1 over x is cosine of 1 over x times the derivative of 1 over x, which is negative 1 over x to the power of 2. All this over the derivative of 1 over x, which is negative 1 over x to the power of 2. You simplify before you continue. And you get cosine of 1 over x, which means that this is cosine of 1 over huge, which is cosine of 0, which equals 1. And the answer is 1. Be careful. 0 over plus minus infinity or plus minus infinity over 0 are two determinant forms that cause a lot of confusion. It's the most confusing determinant forms. I'm going to use the fact that infinity and 0 are reciprocals of each other to show you how to deal with those forms. 1 over plus minus infinity is 0, 1 over 0 plus is infinity, and 1 over 0 minus is negative infinity. 0 over plus minus infinity is just 0 times 1 over plus minus infinity, but 1 over plus minus infinity is 0. And I get 0 times 0, which is 0. That's why this is the determinant form, but it's a very confusing one. Now let's see what is the other one. I just have to rewrite it as plus minus infinity times 1 over 0. Instead of a quotient, you just write it as product. Now I see that 1 over 0 is plus or minus infinity. And I have a product of plus minus infinity times plus minus infinity, and this is infinite, plus or minus, depend on the signs. The limit of x approaches 0 from the right of ln of x over x. ln of x when x approaches to 0 plus is negative infinity. And x obviously is 0, so this form is negative infinity over 0. First of all, it's clear that I cannot use L'Hopital's rule because L'Hopital's rule has to be plus minus infinity over plus minus infinity or 0 over 0. But even more, this is a very easy limit. You just have to write it as a product. Now when this is a product, it's very easy. Because 1 over x when x approaches to 0 plus it's infinity, and ln of x is negative infinity, and infinity times negative infinity is negative infinity. Another such example. Limit x approaches infinity of e to the power of negative x over x. Again, we observe that this is 0 over infinity. And because of this, you cannot use L'Hopital. But I'm just going to write it as product. And I get this product. 1 over e to the x when x approaches infinity is 0, and 1 over x when x approaches infinity is also 0. And I get 0 times 0, which is 0. Be careful from those forms. They are very, very confusing.